Let's take a look at these logarithms and their properties. Properties of logarithms. I've got a couple of videos that goes through this, but let me go through a video with my notes here. Use the property of logarithms to combine expressions as well as to separate expressions. So we're going to do a little bit of both here. So don't forget that answers to logarithms are exponents. So logarithms are exponents, so they actually follow the same rules that you learned in Algebra 1 about the properties of exponents. So, for example, if you have a product inside a logarithm where base is b, you can split it into two logs. Pun intended, you can split the log into two separate logs. Notice the word log is there twice now. And you add the two together. Because remember, when you multiply powers, you add exponents. So see how that's connected there, because answers to logarithms are exponents. So for an example, if I had the log, I'll just do base 10. I'll leave off any base. Log of 5x. I could rewrite that as log 5 plus log x. Let me give you another example. Log of 10. Now, how could we split 10 up into two numbers? Well, log of 5 times 2. So this would be the log of 5 plus the log 2. Now, we went over this in the last video, but the log base 10 of 10 is 1. So I'd love for you to try it in your calculator. Try typing the log of 10 and hit equals. It should say 1, hopefully. And then type log 5, close the parenthesis, and then plus log 2. And it should say 1 again. Isn't that kind of cool? You can split up a log. When you have two things multiplying, you can split it up into the sum of two other items, the two logs. Okay, quotient is very similar here. Quotient, logarithm of a quotient. So if quotient means dividing. So you see we have a fraction, so that's division. And all that happens is that the variable or the number that's on the bottom ends up being second and becomes negative. So anything on the bottom becomes negative. So a simple example here would be let's do another log base 10 example. So log of 10 divided by 2 would be log 10, which is 1, by the way, minus log 2. So you could try typing that in your calculator and see if it actually works out. Log 10 minus log 2, and then type in the log of 10 over 2, which is 5, by the way. With some variables, log of x over 3 would be log x minus log 3. Now, what happens if I stick a y on the bottom also? Well, because that's in the denominator, it is negative as well. So minus log y. So that's a good example there where I snuck that extra variable in the denominator. And I want you to notice that everything that was in the denominator has a negative sign in front because it's a negative exponent, actually. All right, what about an exponent on the item that's inside the logarithm? So you see how we have an exponent inside the logarithm here. Well, as you've seen in my other videos, if you've watched them, I like this animation. I can't really do the animation here, but this exponent flies out front and becomes a coefficient. You see how the exponents can be, quote, thrown out front is what I like to say, can be thrown out front as a coefficient. So this can be really helpful in simplifying things. So for example, log, remember this is log base 10, whenever I just write log, it's log base 10 of 10 to the 5th power. That's a really pretty big number. That's a 1 followed by 5 zeros. I'm not going to write that out. Instead, what I'm going to do is throw that exponent out front. 5 log 10. See how I threw that exponent out front? And then remember, this is just 1, so 5 times 1, this whole thing simplifies to be 5. Thanks to that power rule, we were able to do that pretty easily. Okay, moving on then. There are a couple special things I want to go over. The log base b of the log base b of 1 of any base is always 0. And this is because b to the 0 is always 1. Anything to the 0 power is 1. Students forget that all the time. They think it's 0. It's not. All right, you've been doing this in maybe pre-algebra problem, definitely algebra 1. Anything to the 0 power is 1. So log base b of 1 for any base, log base pi of 1 is 0. Okay, what about log base b of b? That kind of sounds strange, doesn't it? Log base b of b. Well, b to the first is the same thing as b. So answers to logs are exponent. So the log base b of b is always 1. So here's an example. Log base 3 of 3 would just be 1 because 3 to the first is 3. Okay, that's one of those special ones. And then this is sort of a spin-off of the last one. We can throw this exponent out front like you saw in my example earlier, right? And then you get n log base b of b. But we just said in the previous special case that is just 1. So that's why it comes out to be n. And you saw that example right here. Remember when we threw that exponent out front? And we just got 5. Okay, so the next process that we're going to do is called expanding. And you've been watching me do this a little bit, but sometimes they get a little more complicated when you have several things going on. So we're going to be expanding this logarithm. So how could we rewrite 14? 14 is 7 times 2, right? So this is going to be log base 3 of 7 plus log base 3 of 2. Now, where did that plus sign come from? It came from up here in our notes. It said, whenever you have a product on the inside, 7 times 2, you can split it into the sum of two things. So that's what I did right here. I split it into 2. All right, what about pi over 4 x? Now, we actually have division, so we could do quite a bit of simplifying here, or expanding. This is on the top, and so is this, but I'm going to circle it in red. The 4 is on the bottom. Okay, so anything on the bottom is going to be negative. So I'm going to write that there. Go back to the blue ones, and then we have log pi plus log x. All right? There isn't a huge reason to be expanding at this point, but we do need to understand the, quote, legal ways that we can expand these logarithms, and this is correct here. Okay. Let's survey what we have on this next problem. We have a product on the top, right? We have a couple variables. They're both on the top. So those are going to be separated in 2 logs with a plus sign. And then we have a variable on the bottom, and that variable has an exponent. So let's just start with the 2 guys on the top, AC. So that would be log base 5 of A plus log base 5 of b, again a product, C, log base 5 of c, a product you split into 2 logs with a plus sign in the middle. And then we have subtract because this is in the denominator. That's log base 5 of t squared. What can we do with exponents? There's one more step we can do here. We're going to throw that out front of this red term, the one that was in the denominator. So log base 5 of A plus log base 5 of C minus 2 log base 5 of T. So that's called expanding. So whenever the directions say expand, you split it up. You split the logs, okay? Split the logs. Now, let's look at a couple more challenging ones here. By the way, this ln, we'll talk about this more this year, but this is the natural log. I mentioned it right here. The natural log is a special log. It's not base 10, it's not base 2, it's not base anything but one thing, and it's called base e. E is that natural base for exponential growth and decay. It's a special number. It's on your calculator. It's like 2.7. I think I might even have it written here. No, I guess not. So it's like 2.7 something. It's Euler's base, and it's a really important number in the natural world. So we need a log to go with that. So they called it the natural log, and it's ln, not in. You may have seen that button on your calculator and you thought it was in, but it's actually ln. Okay, so here we have a logarithm, and I see multiplication. So I'm going to split that into log x plus the natural log of the square root. Now remember, square root can be written like this: x squared plus 3. A square root is a 1/2 exponent. All right, what can we do with exponents? We can throw them out front. So this becomes the natural log of, we got to follow our rules and don't make stuff up, folks. You'll see what I mean here in a second. This was an exponent on the entire thing that was inside the logarithm, so I was able to throw it out front of that logarithm. Now, did I go over any rules about the sum inside a logarithm? Look back in your notes. Think about it. No, I did not, because there isn't one. This is the best we can do, folks. And you might be wondering, what about that exponent? Nope, the exponent is only on this one term, so it cannot be thrown out front. So this is the best that we can do in this question. Let's see what other kind of goodies we have here. This one's not too bad. All right, we got log base 8, and we have, this is a product up top, and then we just have an entire term, it's called a binomial, on the bottom. So this is going to be log base 8 of 8 plus log base 8 of x minus log base 8 of the quantity, the number. This is a single number, it's just written as a binomial, 2x plus 1. Now this guy cannot simplify at all. We're done over there. You can't split this up anymore. It's because of this plus sign, messes everything up, and it's just a single number. It's a single factor inside that logarithm. Now there is one thing that we can simplify. One thing, one thing that we can simplify is right here. This is equal to 1. See my hint there? Plus log base 8 of x minus log base 8 of 2x plus 1. Okay, that's called expanding. Now, what about getting the wood glue out here and putting these logs back together? That's called condensing. So when you put things back together, it's called condensing. When you blow them up, when you cut them apart into separate logs, it's called expanding. So watch for those two key words, expand and condense. Okay, what a mess here, right? They're all log base 2, so that's something to note. So what do we do first? Well, you know what I would do is take this and put it inside the logarithm. Remember, we're trying to put things back together now. So this would be minus log base 2 of 5 to the 1/2 power is the square root of 5. 5 to the 1/2 power is the square root of 5. This one right here would be log base 2x, and I'm going to throw that up front as an exponent, so it's a 7 in there. So I'm tucking everything inside the logs first. Notice my strategy. I'm putting everything inside the logs first. And now I have addition and I have subtraction of separate logs. So I can write one logarithm. And here's the way I like to show students to do this. Is since we have a minus sign, we know we have a fraction on the inside. So just draw the fraction bar. Just draw the fraction bar first. Anything with a negative is going to go in the denominator. So we have radical 5 in the denominator. And then we have a 4 times, not plus, 4 times x to the 7th in the numerator. You see how I put all that back together again? So it's kind of like figuring out the original question before expanding it. All right, let's take a look at this next question. You might want to pause the video and give it a try if you can. So what can we do here? Well, I see this that can go up top here. So log base 5 of 8 minus log base 5 of the third root of 12. And then we have a big plus 6 at the end. The plus 6 is kind of on its own, so I'm not sure there's much we can do there with that, honestly. So let's just write log base 5 of, do we have a negative? Yes, we do. So that's going to mean a fraction. And we have 8 on the top. We have the third root of 12 goes at the bottom. And then after all that is said and done, we would add 6. So this is how I would condense it. All right, so one more question here, a natural log this time. A natural log. So I'm going to show you an extra step, I think, in this one. So right here, we could attach the natural log of e to that, because why not, right? Natural log of e is just 1. It's log base e of e, and remember from one of our special situations, that's just 1. I'm going to do that, which means this would be the natural log of e to the third, minus the natural log of x squared minus 4. There's nothing that can happen there. Plus, over here, this would be the natural log of the third root of x minus 2 squared. Now I'm going to put the logs together. This would be the natural log of, I know this is kind of a lot, but I'm just following the rules here. And I do have a negative sign, so this x squared minus 4 is going to land in the denominator. I'm going to have an e to the third, in the numerator. And then I have a third root of x minus 2 squared. So that one was pretty tricky. And I wanted you to show you a little sleight of hand that you could do if you wanted to actually get that 3 inside the logarithm. You have to put the base there, base e in that example. All right, so using logarithms to solve some equations, you want to get all the logarithms to one side, and then you simply use your condensing and such, and then rewrite it in exponential form. So this is pretty easy, actually. What you do is everything's inside the log already. So I can rewrite this as log base 3 of 2x equals 4. Right? I just use my property from today to condense this side. So if we want to put the word condense there, not a bad idea. We're just condensing that. And now we're going to rewrite in exponential form. So here we go. 3 to the 4th power is 2x. So what does that mean x is? X is, this is 81 divided by 2. There's the answer, 81 halves. Okay, so we just solved a log equation. We couldn't have done this before because we cannot write this in exponential until we glue it all back together and condense it down into one logarithm. All right, another example here. I said get all the logs to one side. So I'm going to subtract the log base 5 of 7 and get it to the left side. Okay. And now I'm going to rewrite this as one logarithm. Log base 5 of x over 7, not negative 7, just x over 7. Because remember, when you have a negative sign, it simply means it belongs in the denominator on the inside of the logarithm. Equals negative 2. So we have 5 to the negative second. Answers to logs are exponents, remember. The base is the base. X over 7. We then multiply both sides by 7. And we see our answer. 7 times 5 to the negative second. Remember, this is 1 over 25 times 7 over 1 equals 7/25. 7/25 equals x. There's your solution to that equation. Remember, when you solve equations, because that's what we're doing here, we're solving equations, we get numerical answers. But we had to use some of our properties of logs to do this. All right, hopefully you found this video helpful in learning how to use the properties of logs to expand as well as condense. So this is the condensing and this is the expanding, and we went through the three main properties were right here, and then we also went through some special cases here. All right, good luck on your assignment, and until next time.